This video lecture is meant to explore the information found in Unit 10.4 on solution equilibrium. We've studied equilibrium before, where you have a substance that is in the solid form. You put it into water and it turns into the aqueous ions. And if we were to do a KEQ for this, this is where you have the concentration of your sodium ions raised to the first power, multiplied by the concentration of your chloride ions raised to the first power, divided by the concentration of the NaCl also to the first power, because all of these have a coefficient of 1. And we studied before that the larger the KEQ number, that meant the more products you had. And so KEQ was a number that gave us an idea of how far a reaction had progressed. Now, for a substance like sodium chloride, which is a very, very soluble salt, that is a kind of a different circumstance. You're going to have a lot of sodium and chloride ions and not a whole lot of sodium chloride salt or solid left behind. We are, in this unit, going to be talking about the insoluble salts. So when we use reference table F and it says insoluble, those are the salts that we're going to be looking at today, because we've been describing them as that they don't dissolve. But in reality, they do dissolve, just like a really, really tiny amount. And so solution equilibrium has a special equilibrium constant symbol. It is Ksp, where the Sp stands for the solubility product. So if we have a compound like PbCl2, so this is one of those compounds where it appears that, chloride's a halide. It should be soluble, but when it's combined with lead, Pb, it is insoluble. Okay, but that doesn't really mean that it's not going to dissolve at all. It will dissolve into lead ions, and it will dissolve into 2 chloride ions, but the amounts that they dissolve into are very, very small. So there's going to be plenty of solid lead chloride in the container. And so notice that this is going to be written up as an equilibrium. Okay, so the idea here is this. There is so very little of the lead and the chloride ions, and by comparison there is so much of the solid lead chloride that this equilibrium expression is only written with the products. So this is going to be written up as, the product Pb plus 2, the concentration of lead plus 2 ions, times the concentration of chloride ions raised to the second power, and then that's it. You do not include the solid salt that was the reactant in this. And so the idea is that these two numbers are going to be very, very, very small numbers, because there weren't a whole lot in there. And if you were dividing that by the concentration of the original substance, it would be so large, the denominator would be so large compared to the numerator, that this number would just be ridiculous. So what Ksp is then used for, the value of Ksp is used to compare the solubility of lead chloride to another insoluble salt. So the idea here is if you go to AE reference table A, you can see that the Ksp for the substance we just looked at, lead chloride, is 1.6 times 10 to the negative 5. So if I ask you to compare the solubility, who's more soluble, lead chloride or silver iodide? Okay. The larger number is the lead chloride, so this is larger, and therefore PbCl2 is more soluble than the substance that is silver iodide. All right, so all Ksp is a number that helps you compare the solubility of different insoluble salts to one another. So this is essentially what you need to know in order to do the problem set that is 10.4, solution equilibrium. So the first thing you're going to be doing is you're going to be practicing showing the dissociation of these substances. This is a similar task that is done in 10.5 where you have to figure out the number of ions in a compound. So you're essentially doing the same thing here. Na2SO4 breaks down into 2 of those sodiums and 1 sulfate. And so you can see here that the Ksp is written only with the products. You do not include the reactant in the denominator. So that's what this first section is, just getting you to practice how to write a solubility product expression. Part B, you are putting these salts in order from least soluble to most soluble using AE reference table A. And so you're just ranking them from the least soluble to the most soluble. And then you're going to explain how you did that right here. And then there's lastly just a few multiple choice, which is giving you a little bit more conceptual practice with this. All right, this is really everything you need to know for solution equilibrium for unit 10.4. All right, thanks a lot. See you in the classroom.